Hello friends, you are watching channel Number Collage. This is our sincere effort to make you understand and like mathematics, science and engineering in a simple and easy manner. In this video, we will understand how to find large heights and distances with the help of trigonometry. We can find large heights of towers like this, trees, buildings, etc., and large distances between the lighthouse and a boat in the sea. With the help of trigonometry. Let's get acquainted with some important terms. First, line of sight. The line connecting your eye and the object you are watching is known as the line of sight. This is the object, the top of the chimney. This line is known as line of sight. Next, angle of elevation theta, the angle made by the line of sight with the horizontal. When you are looking up to watch an object is known as the angle of elevation theta. So this is the angle of elevation theta. Angle of depression phi, the angle made by the line of sight with the horizontal. When you are looking down to watch the car is known as the angle of depression phi. A balloon is connected to, this is the balloon, a meteorological ground station, this one, by a cable of length 225 meter, inclined at 60 degrees to the horizontal. Determine the height of the balloon from the ground. In right triangle ABC, hypotenuse AC and angle ACB equals 60 degrees is known. So we will make use of sine ratio. We have sine 60 degrees equals AB divided by AC. AB divided by AC. We have sine 60 equals AB divided by AC. In this triangle, sine 60 is root 3 divided by 2, which equals h divided by 225. It gives 2h equals 225 root 3. H becomes 225 root 3 divided by 2, which will be 194.86 meter. So the height of the balloon will be 194.86 meter. A vertical stick of 10 centimeter long casts a shadow of length 8 centimeter long. At the same time, a tower casts a shadow of 30 meter long. Determine the height of the tower. The sun rays are parallel. In right triangle ABC and triangle PQR, angle C equals angle R equals theta, say. In triangle ABC, tan theta is AB divided by BC, which will be H divided by 30. In triangle PQR, tan theta will be PQ divided by RQ, which will be 10 divided by 8. Which implies H divided by 30 equals 10 divided by 8. It becomes 8H equals 300. H will be 300 divided by 8, which will be 37.5 meter. So, height of the tower will be 37.5 meter. A vertical straight tree 15 meter high is broken by the wind in such a way that its top just touches the ground. And makes an angle of 60 degrees with the ground. At what height from the ground did the tree break? We have to find this height, which is x here. Let height of the broken part from the ground AB equals h. Upper broken part AD will be 15 minus h. Part AD will sit on AC, so that AC will be equal to AD, which will be 15 minus h. AC will be 15 minus h. In triangle ABC, sin 60 is AB divided by AC. In this triangle, sin 60 will be root 3 divided by 2, which will be h divided by 15 minus h. This gives us root 3 multiplied by 15 minus h equals 2h. We have root 3 times 15 minus h equals 2h. Opening the bracket, it will be 15 root 3 minus root 3h, which will be 2h. Now taking minus root 3h to the right hand side, we write 2h plus root 3h equals 15 root 3. Taking h as the common factor, we write h times 2 plus root 3 equals 15 root 3. So h will be 15 root 3 divided by 2 plus root 3. We will rationalize the denominator by multiplying numerator and denominator by 2 minus root 3 divided by 2 minus root 3, which is the rationalizing factor of 2 plus root 3. So 15 root 3 times 2 minus root 3. In the denominator, 2 plus root 3 multiplied by 2 minus root 3 will be 2 squared, which is 4, minus root 3 squared, which is 3, which will be 15 twos are 30 root 3, minus root 3 multiplied by root 3 will be 3, 15 multiplied by 3 will be 45, and 4 minus 1 will be 1. Now substituting the value of root 3, which is 1.73, we get 30 multiplied by 1.73 minus 45 as 6.9 meter. So the tree broke at a height 6.9 meter from the ground. Two poles of height 6 meter and 11 meter stand vertically on the ground. If the distance between their feet is 12 meter, find the distance between their tops. Mark points A and B as shown. Join A and B. Draw a horizontal line leftwards through B. To intersect left pole at C. BC equals EF equals 12 meter. BC is 12 meter. AC will be 11 minus 6, that is 5 meter. 11 minus 6, that is 5 meter. In right triangle ACB, AB squared equals AC squared plus BC squared according to Pythagoras. AC is 5, BC is 12, so it will be 25 plus 144, which is 169. So AB will be square root of 169, which will be 13 meter. So 13 meter is the distance between the tops of these two poles. From the top of a tower 50 meter high, top of the tower 50 meter high, the angle of depression of the top and bottom of a pole are observed to be 45 degrees with the top of the pole and 60 degrees with the bottom of the pole. Find the height of the pole. If the pole and the tower stand on the same plane, draw a vertical line AB through top of the tower. Mark the points C, D and E. Draw line CF horizontal through C to cut AB in F. By concept of alternate angles, angle ACF equals angle EAC equals 45 degrees. Angle ADB equals angle EAD equals 60 degrees. FB equals CD equals H because of a rectangle. AF equals 50 minus H because AB is 50 and FB is H. Let BD equals X. In right triangle ABD, tan 60 is AB divided by DB. But tan 60 is root 3 divided by 1, which is root 3. AB is 50, DB is X. It gives us X equals 50 divided by root 3. So CF becomes X, which is 50 divided by root 3. CF 50 divided by root 3. In right triangle AFC, tan 45 is AF divided by FC. AF is 50 minus H. FC is X. And tan 45 is 1. It gives us X equals 50 minus H. We have X equals 50 divided by root 3 also. So we write 50 minus H equals 50 divided by root 3. So H becomes equal to 50 minus 50 divided by root 3. H goes to the right, 50 divided by root 3 goes to the left. Taking 50 as the common factor, it will be 50 times 1 minus 1 divided by root 3. Root 3 is 1.73. It will be 1.73 minus 1, which will be 0.73. 50 multiplied by 0.73 will be 36.6 divided by 1.73 will be 20.10 meter. So the height of the pole H will be 20.10 meter. This is the first part of how to use trigonometry to find big heights and large distances. In the second part, we will discuss more problems on the same topic. If you like this video, please subscribe this channel, share this video with your friends and relatives. Thanks for watching. Have a nice day. Keep watching Number Collage.